next up we have Grace, who's going to be talking to us about how containers fit into the serverless landscape. Over to you, Grace.
Amazing, thank you. As we can see, my obnoxious Stanley Cup is very likely to fall off, so you can all have a laugh about that at some point. So on the drive over here this morning, I was thinking, I'm going to start talking about containers at serverless days, and people are going to like roll their eyes at me or throw things. However, loads of people have mentioned containers today, which reinforces the point I'm about to make. So actually, they've made my job easier. So love them or hate them, containers do have their place too. Who's working with containers in any capacity? Oh, so there we go, right? Who hates working with containers? Oh, okay, we've got any Kubernetes fans? All right, yes. Sorry, James. He went to throw my laptop because there's the one sticker I've got is Kubernetes. Anyways, they do, right? And we know that, and listen, I love serverless. I do a lot of stuff with serverless. I'll tell you about what I do in a moment, but I really do. But they do have a place, right? There are things that don't fit within the traditional kind of Lambdas function as a service, all the different ones we've learned about today. We have our long-running processes, things that are going to exceed that 15-minute time cap. We have our batch processing, where we're going to have huge amounts of data coming through, or whatever it is that we're going to be doing. Sometimes we've got legacy code. It does still exist out there in the ether. I worked in public sector. There is a scary amount of it. Any public sector people here? Okay, yeah, so guilty. You know what I'm talking about, right? It's there. It's not going anywhere just yet. Hopefully, at some point. Sometimes you have really complex dependencies and runtimes, so sticking it in a function as a service is just not that simple. And then sometimes, and I know having worked for two big cloud vendors now, we're not supposed to say to avoid vendor lock-in, but sometimes we want to avoid vendor lock-in. And we also have hybrid and multi-cloud deployments where actually we want to be able to kind of have an approach that makes that easier. But I am aware that I am at the Serverless Days event, I promise. I did actually know what I was signing up to. So with that in mind, we know these are the principles, okay? We want things that are going to have that event-driven architecture, regardless of whether we're using containers. We want automatic scaling. We want pay-as-you-go pricing. If you've ever been to a workshop hosted by a cloud provider, you've heard the pitch, the why you go to the cloud. We want statelessness, and to the point that a lot of us make, we know that serverless doesn't actually mean no servers, just not my servers. I don't want to have to deal with them. They're not my problem. So with that in mind, and given some of the things we've actually heard about today, let's think about then how we can actually still use containers when we're forced to, but keep all of this event-driven kind of best practice around serverless in place. So with that in mind, welcome to this talk, Hold the Functions, Containers Can Be Serverless Too. My name is Grace Briody. I am a technology specialist. Job title doesn't really mean anything. Effectively a solutions architect in the app innovation team at Microsoft. Currently working with FSI customers, so financial services. Before that, I worked as a solutions architect at AWS for a couple of years. There's still a debate on whether I've gone to the light side or the dark side. You can work that out. It depends who you ask. But a big part of my job as app innovation isn't just containers. So app innovation looks after all integrations, all things serverless, developer productivity, GitHub, my new favorite thing in the entire world. And so everything. So while I am a big fan of containers, and I've spent a lot of time on it in the last few years, obviously it fits as part of a wider strategy. So I know a lot of people here have got 10 times more experience than me, so bear with me for a second. We do have people that are also still earlier in career or haven't worked with containers. So just to level set, because we've heard about them today, just so that this makes sense as we go through, I'm just going to take a second. What are containers? Really, we're talking about, we have an app. We take our source code, all the dependencies needed to run it, we pile that together into a container image. When we then want to have that app accessible, we deploy it onto a compute node, which is a server or a virtual machine, that has a container runtime running, and voila, with a little bit of magic and some networking, we can access our application. How do we deal with all the things we talked about today, performance, scaling, etc.? High level, we've got kind of two general concepts. We either can increase the memory and the CPU, which is our vertical scaling, i.e. throw more power at it and hope that it can serve all the traffic coming through, or do horizontal scaling. We have multiple instances of our container running. So for those more familiar with functions as a service, we know that obviously every time you get a new request, we scale out, we have more of them. As we heard, I think Paul might mention in his talk, sometimes containers take multiple requests, and so we might need to scale out regardless. And then controlling them at scale. So this is the bit where container orchestrators come in. Anyone working with the classics, ECS, EKS, AKS, anyone actually having to do raw Kubernetes? Is there any? Okay, we've got one few people. Red Hat OpenShift, we've heard of them. But for those that are completely new to this, their job effectively, one container is one thing, but imagine when we get to the point, I think we talked about 15,000 at high scale, right? Well, how do you place them on virtual machines? How do you deal with rolling updates? How do you do with health checks? All of the things that need to be done. Once upon a time, somebody might have sat there and very sadly had to kind of manually do these or write scripts. Container orchestrators effectively provide all the tools and APIs to kind of automate all this. So just to set the scene, that's what we're talking about today. So in the beginning, when we think about containers, it actually was just like a step up from hosting things on virtual machines, right? To my point about orchestrators, you still have to provision the underlying cloud or physical resources, so you would still need to go in and do that. People here may have heard of node groups, where you kind of go in, you choose the compute instances you want, but you still have to log in, do all of the updates, no different. The main difference was just that instead of running effectively, your compute resources are better because you're actually just running lots of containers, and you've kind of, I won't get into all of that. But as serverless took hold, and we know that it's become a really big approach, obviously the cloud providers said we should probably do something about this and actually offer that so that we don't have this management overhead. And so serverless has really taken over in the container space as well. At kind of a high level, you don't need to declare as much, but you still need to say, what CPU and memory your containers are going to need to run, any GPU requirements, some of the basics around kind of what this container is going to need. You then get advantages of the per second billing that we're used to with serverless. You get no node management, so again, not my servers, they're someone else's. With that, there's the trade-offs. As we know, when we trade off for managed services, we also then don't get control of the underlying infrastructure in the way that we would have done normally. So we do know that we've got to make that trade. That's not always possible, so serverless doesn't always work for everybody. We know that anyway, but this is the same concept. So all the things you already knew, they still apply. We're just talking about containers. So I mentioned I work for Microsoft, so I'm going to just set the scene a little bit using Azure as an example. But to be clear, nearly everything I talk about can be done in other clouds. There are similar tooling, and I'll reference it where possible, just so you've kind of got that knowledge to take away. Has anyone worked with Azure Container Apps? Have we got anyone using it at the moment? James, the one advocate, has started writing some good blogs on it. Okay, so for people that know AWS better, think ECS. The difference is Azure Container Apps is actually built on Kubernetes. So it is a fully managed container orchestrator, but built on Kubernetes. And for those who do love Kubernetes, all 4 of you that put your hand up, it means you do get these beautiful open source tools as part of still having a managed container platform, which I am very relieved about. So things like automatic scaling with Kada, I'm going to dive into that very shortly. Things like Dapper support, if you follow James, you probably do. Most people, you'll hear him starting to talk about the amazingness of being able to use this for, simplifying communication between your microservices, and also native integrations with Azure Functions, which is our Functions as a Service app. So you actually get to tap in to some of those open source things that without having to actually touch Kubernetes, which is a relief for a lot of people. Paul kind of alluded earlier to another talk I used to do, which was kind of EKS versus ECS. And I'm the first to say I love Kubernetes. It is absolutely not the answer for like 90% of the questions. Like ECS generally does the job, okay? It's no different here. It's just that sometimes we do still want to use a little bit of that kind of extensibility that we get with it. Let's go through some problems then. So event-driven patterns. So I mentioned traditionally when we would do sort of scaling, we would say, CPU and RAM. So like, let's throw some more memory and CPU at this. Let's, allow that scaling to happen. That's not very event-driven, okay? And we've seen some really great patterns today around where, containers are still in play. And the focus wasn't on that. It was on all of the event stuff happening around it. But then how do we bring that in? And as I mentioned, I'm going to talk about Azure Container Apps and Kada. However, this can absolutely be done, most of these, using ECS and using custom metrics. So there is absolutely a way to do it for people to go, look. So we can still scale using CPU and memory. That's always useful. But we then also can look at things like concurrent HTTP requests. So this was something that was referenced earlier. We might say, actually, at a certain point, when we get too many requests come in, let's add another instance. Let's add another container so that we can now load balance our traffic. We also, though, can use events. So our service buses, our event hubs, our queues, all of these places where we, throw, and we've had so many talks about this today around, good practice around that. We know it's a core part of decoupling things. And actually, that could be a great way to kick off the scaling. That could be a great way to actually start the container, not just scale things up and down. You can also, a lot of open source tools, so Kafka, hugely used by a lot of my customers when I was at AWS. Obviously, Redis, massively in use, RabbitMQ for people using the sort of a cloud agnostic tooling. Custom metrics, and then interestingly, DB queries. Don't know if anyone had ever come across this, but you can literally query a database, return a numerical value, and that can be the metric passed in to your CADA policy to scale things. Don't know if anyone else found that interesting. I did, so I thought I'd tell you. But yeah, so we've got this full kind of flow of things that we can do. So now we have serverless, but we're also event-driven, right? So what does this look like? So in the Kubernetes, in the CADA world, this obviously is not what a policy looks like because I wasn't going to try and write one, but high level, it looks something like this. We'll say we're using Azure Service Bus, so this is our pub sub-service, so we're going to throw, messages at it. We want to obviously, get those messages and do something with that event. In our policy, we simply say, what's the event source? So where is this coming from? So obviously, CADA, all the ones I mentioned, it's a custom integration, custom metrics, and obviously you kind of have to write a little bit extra. And then for this one, it makes sense to be like the number of messages in a queue. So whatever that number is, whatever makes sense to your business logic. Obviously, minimum replicas, we can scale down to 0. We're going to talk about latency in a moment, because obviously we know that that's where that comes in. And then maximum replicas. So again, nothing wild or fantastic here. People know how kind of general scaling works, 0 to whatever number you want. What actually happens then is CADA will have this continuous iterative loop where it will monitor the queue, see if there's anything in the service bus, and when it is, it will then kick off and send instructions to the Azure Container Apps to begin that scaling process. So pretty simple. And as I say, all of this can be done using other cloud providers. I don't know about Google, I'm afraid. I've never. 2 clouds is enough. I'm at my max for the moment, maybe next century. Okay, cool. So, that was very loud. Next one. Next problem. Long-running, spiky workloads. Okay? So we know that we've got lots of things that can't be avoided, and that's where the containers bit comes in. I mentioned batch processing, media uploads, transcript generation, report generation. There's loads of it. Is anyone getting to work on any kind of Gen AI projects at the moment? We've got a few hands. Okay, so obviously you can imagine, a big part of my job at the moment is helping customers build Gen AI workloads. It's very fun, mostly, sort of. Loads of stuff around like taking huge audio kind of recordings, doing some stuff for healthcare customers, and then, doing these transcripts. And so, these really sort of weird workloads where, it might be that there's peak hours, or it might be that in the world we live in, things can just spike up and down, and there's kind of no kind of like easy way to do this. But we still want to be able to scale to 0 when we need to, and this is quite a key concept. We might have a moment where we have like 100 videos in 10 minutes, and then we might have nothing for 4 hours, and we want to make sure we take full advantage of this. Before we go into that, however, not all containers are the same, okay? Obviously, Gen AI made this. You can tell I'm not that artistic, and I was so happy. I was having so much fun making these slides. I'm not going to lie. ChatGPT, too much fun. Anyways, let me not digress. So we think of containers as these ongoing things, and we tend to think we deploy a container and actually it's going to just stay living. If you know containers, they're actually immutable, so that's not entirely true, but they stay there, they're serving traffic. But actually, that's not really applicable to a lot of workloads. So in the world of ACA, we have jobs. In the world of ECS, they're called scheduled tasks. I don't know if anyone's kind of worked with scheduled tasks. But the idea is that these are like single-use containers. The only, the great thing is they're guilt-free single-use containers, which is not something that we get very often anymore, but they are single-use, right? They do their job, and then they're destroyed. And so actually, sometimes, for some of our workloads, this would make sense. So when to consider jobs? Things like this beautiful slide. So batch processing, things that might be running kind of periodically or on demand. Examples might be like processing large data sets, performing data transformation, generating reports, those things that obviously are going to kind of, run at various times and intervals. Scheduled tasks, so things like, database backup, system maintenance, sending out periodic notifications, things where you're going to know, think cron jobs for those who've played around with them. Obviously, event-driven tasks where a thing might happen, but actually once it's done, it's done. And an example could be having like an e-commerce website, and actually when, you know, an inventory, you know, sorry, when an order comes in, some inventory processing has to happen, but then it's done when it's done, right? And we don't need this container to continue living. And then obviously another one is like finite duration tasks. So things like, you know, running a machine learning model to make predictions, you know, doing that kind of, you know, inference that we talked about earlier, maybe like a one-time data migration. So my first kind of thing when we're talking about those kind of long-running spiky workloads is first make sure you're using the right type of container. Is it actually traditional containers you want, or would jobs or kind of scheduled tasks do the job you want to do? Now, if these don't work, and you are going to have to kind of still use normal containers, and actually, to be honest, to some degree, even with jobs, one of the things that we know we need to talk about is latency. Now, I'm afraid to say I don't have an AWS answer for this. There probably is one. If someone knows it, feel free to write a talk about it, and you can have this spot next year. But I don't know. But I can talk to you about how it works with Azure Container Apps. I don't know whether it said Envoy or Envoy. It's going to come out different ways each time, so it's fine. But what is it? Effectively, it's a proxy that's going to sit in front of your containers and be able to buffer requests as they come in. So let's just say we do scale down to 0, but we don't want loads of latency as things come in, okay? So one way to achieve this would be to make use of this integration that we can have with this open source tool. So how it actually works is that you don't change slides. So Envoy will monitor your environment, or monitor the traffic, sorry. When there are no active requests, it can scale down to 0. That's fine, it can sit there. Obviously, Paul kind of talked about it a lot earlier, but there's scale-up times. Things don't just kind of appear with containers. And if they're big containers, sometimes it could be 30, 40, 50 seconds before it could actually service traffic. So to be clear, I'm not suggesting that you do this if you have like sub-millisecond requirements. But when you're doing things like media generation, report generation, batch processing, this is fine. What you don't want, however, is for your client to send a request and for it to just kind of go unanswered because it's going to take 40 seconds to actually pick up the request. And you want to, you know, we know we can use services in the middle, we can decouple it, but we still want sometimes to just kind of point that request forward. So once that request arrives, the container app is then scaled, so it's scaled down to 0. The request arrives, and what will happen then is this request buffering happens. So it's going to hold on to the incoming request. I'm just not even going to touch that. It's going to hold on to the incoming request, effectively store it in a queue, while your container is able to then scale up. And as soon as that container is able to take the traffic, it's able to then forward on the request. And so the client's happy, it's not had to wait, it can see that its request has been held on to, and it's been responded to, but it provides that little break in the middle of it. So really useful for dealing with this latency issue. So let's recap where we're up to so far. So we know we can scale to 0. We know that we can do things in an event-driven pattern. We know that we can choose between traditional containers and one-off jobs, and we know that we can reduce latency. So the final thing I want to talk about is functions and Azure Container Apps. Better together, obviously Gen AI. And I left it in there because you can see, I don't know what funds, I assume that's meant to be function apps, is meant to be. Don't use Gen AI for everything, but you know, it's quite fun if you do want to do it, and it does come up with some interesting results. Okay, so what am I talking about here? We actually kind of got some interesting information earlier about the way that actually functions as a service generally run underneath the hood, which is that things are kind of containerized generally and sort of, you know, put in a function. And often we run these things separately, okay? It's very rare that in very complex things, a lot of my customers are using both. And there's the element of some things are being done with a container and then it's handing off a lot of stuff to functions or to Lambda, right? That's a common pattern because we don't want everything, all the business logic sitting in. That doesn't make sense, right? We want to decouple stuff. But what we then end up having is 2 environments, right? And we've got our clusters of whatever way you've deployed your containers, and then we have our observability around our functions. And obviously they'll be deployed, if it's in the AWS world, maybe that is inside of a virtual network, and that helps a little bit with kind of capturing stuff. But we still know that we obviously need to manage these 2 sets of traffic, despite the fact that they're often talking to each other and doing kind of part of the same big process. So at a very high level, this is what we're talking about. If we imagine you can run your Lambda, no, you can't run your Lambda functions on Azure Container Apps. I did not say that. You can run your Azure functions on Azure Container Apps, Azure Container Apps. Anyways. And so what this means is you actually deploy them straight onto an Azure Container App environment. And that can be the same environment that you're running containers on. So we can choose both, right? So if we imagine we spin up this cluster, this environment, we can deploy them both containers and functions into the exact same environment. They're both effectively running on the same technology, but they're actually now sitting in the same place. So if we think about some of the things we said we could tap into when we use Azure Container Apps, like using things like Dapper and CADA and all of these open source tooling, we now can apply them to our functions. So we've now got things that we didn't have access to before because we've put it in this new environment. We also, it means that we have a single place to monitor when it comes to things like monitoring tools, cost management, getting our application insights and all that other stuff. So we actually get this full kind of, place, all of our networking security groups, all the things that we think about that historically we've had to do in two places because we have things running in two places. When it makes sense, because these are talking to each other and there's a lot of communication and they're part of that same kind of process, putting them together like this could be a really good way to actually simplify and sort of solidify this down. So just something to think about, just something to take away. Cool. So just to kind of summarize a little bit, use events to scale your containers. CPU and memory work sometimes, but it's not a very good pattern and it isn't something that makes sense a lot of the time. It's become easier and easier. I know, obviously, and I think Dave made a joke about it earlier, I don't work for AWS, so I can say more things now. They actually do have really good blogs on this. There's some really good content. Microsoft obviously has put a lot of effort into building up this container apps project, thing, and providing all of the integrations and stuff. So definitely go and look at it if it's not something you're doing already. Really do look into these guilt-free single-use containers. They're not something that people kind of look at as much as they should. They make a lot of sense. And it means that actually when you don't have to scale to zero, they just die and they're gone. So it's not your problem and they're done and they've run out. So just around that kind of you're not having things sitting around not being used. And also, think about how to reduce that latency when scaling to zero. I'm afraid, as I say, I don't have the AWS answer, but hopefully if you're using Azure, it's something you can look at. So hopefully that was useful. I actually managed to run within time, which is a new record, so I'm very happy about that. So thank you for coming to this talk. You'll find me on LinkedIn, Grace Briody. If you want to connect, ask some more questions. But I hope you enjoy the rest of the event. And enjoy the networking afterwards. Thank you. Okay.